Doing every challenge question, chapter 8 of Core Pure 1. This is the induction chapter, which is fantastic. So just let n equal 1, and if n is 1, this is just one term to sum up. It's just minus 1 to the 1 into 1 squared, which I believe is minus 1. And then you can check this side. If n is 1, you get a half into minus 1 to the 1 into 1 times 2. The half and the 2 cancel, you just left up with this minus 1 here. So it checks out for n is 1. That's good. Let's assume it's true for n equals k. So let's just replace all these with k's. And we're going to assume that this is true. Good, and now we're going to see what happens if n is k plus 1. So let's put in k plus 1 into this top bit here. And now, of course, this thing here is the sum from 1 to k plus what happens when you do k plus 1 in here. So it's just the sums up to k, and then just the last term I've written separately here, putting k plus 1 into here. Now this, by the assumption step, is just this here, so I'll replace that there. And now we can do some clever factorizing stuff here to make this work out, I think. I'm going to factorize out, well, firstly, I can write this as minus 1 to the k times minus 1. And I can also factorize out half, which involves putting a 2 here, because a half times 2 makes the 1 that's here, because there's no number here. And I can also factorize out k plus 1 from this as well. And that's super useful, because now I'm going to do some more stuff, which is I'm going to factorize out the minus 1 to the k, I believe, and leave behind just a k, and then minus times 2 is minus 2, times this is minus 2k minus 1, minus 2, sorry, and we get this, which is, of course, minus 1k minus 2, which I can then factorize out a minus 1 from, and put that minus 1 into this guy here to make a minus 1 to the k plus 1, because there's just one of them there, so I add the powers. And I think this then, if I factorize out minus 1, becomes k plus 2, and this, although I've written it in the wrong order, is entirely what this is. If you use k plus 1 instead, there's a k plus 1 there. There's a n has become k plus 1, and n plus 1 has become k plus 2, and so therefore we are done. Although it was a bit of a mess for me to get that. Next one, same thing. So let's set n equals 1, and we'll just verify that this works. Of course, this power 1 is just itself. This with 1s in it is just this, because this becomes 2 over 2, and this becomes minus 3 over 3, which becomes 1 and minus 1. And so that's all fine. So it works for n equals 1. Let's assume it works for n equals k. So this is the assumption which we'll use. And now let's investigate k plus 1. That should be an equal sign. Apologies. So now let's think about k plus 1. So replace that with k plus 1. Of course, with the matrix things, what you do is you say it's the matrix to the k times the matrix to the 1 by the assumption step, because you're always trying to force the assumption step into these. This thing here is just that thing there. And now let's just multiply this out, because of course this to the power 1 is just itself. So we're going to do 3 times this, or 3 to the k times this, plus this times 0, plus this times 0 is just 3 to the k times 3. And then next bit will be this times this, plus this times this, plus, what's the last bit? So this, which is 0. So we just get those two terms. And then this is just 0. Just keep going along that. You eventually get this here. Now, there's a lot of stuff we can do to this. Firstly, this is 3 to the 1, so you add the power, so this becomes 3 to the k plus 1, which is great. Likewise, this becomes 4 to the k plus 1. This here, you could write as 2 lots of 3 to the k over 2, plus this, and then group them together, because the denominator will be the same. So 2 lots of 3 to the k plus 3 to the k is 3 lots of 3 to the k minus 1, and likewise down here, this is 3 lots of 4 to the k over 3, and then it's 1 minus 4 to the k minus 3 lots of 4 to the k, which is 1 minus 4 lots of 4 to the k. So that all turns into that. And then this, of course, is just 3 to the k plus 1, and this is 4 to the k plus 1, and this is perfect now. This means, based on this, k's are all there. Here, k plus 1 has just become k plus 1 every time. And so it's true. By the way, I should have said we should do these conclusion that we do. So we said it was true for n equals 1, and we have now shown it's true for n equals k plus 1, so therefore it's true for all integers k, something like that. Just give the usual spiel. Anyway, now we have the last one here. So m is this. We're going to show this thing here. So again, test n equals 1. Of course, m to the power 1 is just itself. And then here, m with a 1 here is just with 1s there, which is, of course, just this. So it's kind of trivially true for n equals 1. Assume true for n equals k. So just put k's in here. That's the assumption bit done. And now we're going to investigate k plus 1 by putting k plus 1s into, by investigating m to the k plus 1, which is, of course, just m to the k times m, like I did last time. M to the k by assumption step is just this, and then m is, of course, just what it was defined to be originally. Now we need to multiply this out, so this becomes cos k theta times cos theta minus sine k theta sine theta, and then that's going to be the top kind of left term, and then cos k theta times minus sine theta and then minus sine k theta times cos theta, that's here, and then likewise for these last two. This is a little bit tricky to spot, but from year 13 regular maths, you've learnt these rules here. And if you just spot, these rules are just in here, right? So this is cos theta minus sine k sine. Well, that's the cos minus sine sine. That's just cos of k theta plus theta, which is cos of k plus 1 theta. And likewise, this one, cos sine, or sine cos, is this one here with the, if you factorize out minus 1, is the plus. So that's just sine of k theta plus theta, which is sine of k plus 1 theta. And likewise for the other two, which is, of course, is done. This is just now done because we've put the k plus 1s there. As this is done, I don't really know what to say here other than doing this rotation once is, or many times after itself, is equivalent to just doing it in one go with n times the angle. Like, I think that's pretty obvious. I don't know, whatever. Who cares? That's the challenge questions done.